Hello and good morning. Here is a small update on the Jinty. So as you can see, it's got its wheels on now and it's got some gears in it. So I thought it'd be a good opportunity to describe how roughly it's going to work. So I might use this motor, I'm not too sure. But essentially this motor will sit inside this gearbox like this. The shaft will be projecting through and out the side of the bearing to hold it in place. But essentially it's going to sit roughly like that. And the rotation of this motor, it was just rotating like this, will bear against this gear here. And now you see this gear here is much more fine than the other ones. It's a helical gear that's designed to work specifically with this worm gear. So that's a 30-to-1 reduction. So if every 30 rotations of the motor, this rotates once. And then this here is, I think it's a 14 tooth and a 28 tooth or something like that. So we're halving it again. So it's something like a 60-to-1. 60 rotations of this motor is one rotation of this middle axle. But you can see, there we go. So these rubber things are, focus. These rubber things are called muffs. And so they are just these little plastic tubes, and these are all different sizes. So this is one for some gears with a little shoulder on it. This is ones for these ones, sorry, are for smaller wheels. These are imperial and these are metric. When you buy a kit, it tells you which ones to use. But essentially, you press the wheels in from either side into this, and the axles don't go all the way through; they stop halfway. So the sides are still electrically isolated. And so that's how you attach the wheels. And what a kind of cool thing is, the Two Mill Association provide loads of jigs and guides, and what you can see here are some spacers. And so this cool little thing is used to center the wheels. So you can see this hole here, and there's a corresponding hole in this plate here. And now these plates just pull out, and there's one, they represent the wheels. So whatever size wheel you've got a corresponding plate in there. And what you can see is it's holding it at perfectly a 90-degree angle. So here the crank pin hole is up, and here the crank pin hole is forward. So you place the wheel in, and then you simply use this to push it into the muff, and you use these spacers to place between the wheel and the body, and between the body and the muff inside. And then you have your rough spacing and gauging. And what that means is that the wheels are quartered together. Now, I've not particularly found quartering all that challenging yet. I've only done it a couple of times, but I didn't find it so much of an issue. But it does seem to be something that trips people up. So yeah, I don't want to speak too authoritatively about it, but essentially you need to make sure that if all of your wheels are, say, in the down position here, that then they're all in the rear position here. And the exact angle doesn't matter as long as they're all aligned, they're all offset by the same, like each axle is offset by the same amount. So then when you rotate, the coupling rod moves very smoothly around. If one of them's off, then like if one of them's like this, you can imagine the coupling rod is going to be moving this way, but this center axle is down rather than forward, then it's going to bind in there. And that binding is the cause of poor running on lots of kit-built locomotives. So you can use this to ensure everything's at 90 degrees. But I think when I did this chassis last time, I still had to quarter it a bit by eye. But that's it. So it's running now. The next thing to do is to do these coupling rods. So that's to solder these up, laminate them, and place them over these crank pins and see what my quartering is like. It's probably going to be out, but that's okay. You can look through. I probably can't do it with the camera losing focus, but you can look through the hole, and you can look through this hole at the top here. Oops. Look through this hole into the back of this wheel, and you can align almost by eye. And then you do two at the same time, and you rotate until they stop sticking, and then you do these two, and until they stop sticking, and then you put the whole thing on and you rotate again. So it's just it's a process of elimination. So then the coupling rods will be on, and I can move it around. So I don't know if the etch is designed like it, but this middle axle, it's not sticky at all, as you can see, but what it is I think it's slightly raised up. So it sometimes loses contact with the surface here, and I don't think I've bent the chassis, but that's actually probably a good thing, because you with a fixed chassis, you're never going to have more than 3 points that are in contact with a flat surface anyway. You know, you're going to have like these 2 points pivoting, and then either this corner or this corner, unless you start springing them. And in the previous build I did actually open up the axles. I think I opened up these 2 axles and added some springs in there. But it actually added so much time to the build, and I couldn't see that much benefit from it. So I left them out this time. But I think that's why. But if as long as there's electrical contact, because this whole body is electrically live, you know, if you remember, there's the dividing lines down there, then it shouldn't matter whether this particular wheel is in contact at any given moment, because this wheel and one of these 2 and one of these 2 will always be in contact just by nature. So it should be able to drive this middle wheel, and then the coupling rod will be able to transmit the drive to all 3 axles. So next time you see this, hopefully it will have the coupling rods on and it'll be running smoothly, and it might even have the motor in it. I'll let you know how that goes.